Okay, here's another example of double replacement reaction. So in this example, we want do a couple of compounds with polyatomic ions. Okay, see if we can work out this, which is a little bit more complicated than the previous one. Okay, so this first compound is called ammonium sulfate. So you have a polyatomic cation and a polyatomic anion, calcium nitrate. Okay, you feel free to pause at any point of the video to see if you can try. I would strongly recommend you have a piece of paper and pencil next to the computer to see if you can try this on the paper. Okay, step by step. All right, so the first thing we're going to identify the ions present. Okay, so the same thing, we're going to list out the cation and anion for both compounds. Now be really careful when you want to carry those little numbers when you don't. Okay, if the little number belongs to the ion, then you do want to carry it. Like in this case, NH4, that's a polyatomic ion as a whole thing with a positive 1 charge. But the 2 down here is not. Okay, the reason you have a 2 down here is because SO4 as a whole thing is negative 2 charge. So basically, this whole compound will need 2 ammonium and 1 sulfate. So that's why there are 2 here in order to be neutral. All right, so if you don't remember these polyatomic ions, okay, especially the charges, feel free to go back to Survival Guide, Module 5, page 4 to look for the polyatomic ions, so list of polyatomic ions. Now the other compound here is calcium nitrate. Okay, cation is the metal calcium with a positive 2 charge. And the anion part is the NO3. Parenthesis 2 here is because NO3 is, as a whole thing, is negative 1 charge each. This is called nitrate. So in order to neutral positive 2 charge with negative 1, you have to double this guy. Okay, that's why there are 2 of them. This 2 is showing there are 2 nitrates. Okay, 2 of NO3s, but it's not part of nitrate. Now the products, you're gonna use the same ions. Okay, the charge and everything will be the same. Just cross-link the cation with the other anion. Okay, and then again, be careful when you write them together. Be careful, balance them the charge as well. Okay, so you can't change what they are. Okay, NH4 is +1, cation in the front, NO3 is the anion goes second. Okay, so positive 1, negative 1 charge, so they're gonna just be like that, 1-to-1 ratio. Okay, plus sulfate negative 2, calcium positive 2, and then calcium in the front. As metal goes front, sulfate next, no charge. Okay, positive 2, negative 2 cancel out. All right, and then you're gonna go to the ion solubility chart. Okay, looking for ammonium. You can see ammonium. Okay, if you look at the ammonium, they're all going to be aqueous. So that's actually, it's convenient to remember that. Any ammonium-based compound are going to be AQ. Okay, now let's look at the calcium. Calcium is here, and if we look at the calcium sulfate, okay, let's look at the calcium sulfate. Calcium sulfate is the second last one. Calcium sulfate, it's right here. You see this one here? Calcium sulfate is I. I here again stands for insoluble. Insoluble means this is a solid. It's not soluble in water. Okay, so these are the products. So we identify the ions, we predict the products, we crisscross link the cation anion, and then we check the solubility of the products. Now here's the thing. For double replacement reaction, okay, you have to have at least one of the products be solid. If both products turn out to be, once you check the solubility here, okay, if both turn out to be AQ and AQ, then that means no reaction if no solid. Okay, so next one will be try to balance the equation. Now again, when you're trying to balance the equation, okay, it's ideally you want to balance every single element. there's so many different elements in this case: nitrogen, hydrogen, sulfur, oxygen, calcium, and here are nitrogen and oxygen again. But just because it's double replacement, okay, we're looking at the cation anion. So we just need to balance the ions without breaking up the polyatomic ion. So when balancing equation here, okay, do not break polyatomic ions. What I mean is, you don't really list out nitrogen, hydrogen as, you just list out ammonia, NH4 as one species. Again, don't include this 2 here, okay? All right, so sulfate, SO4 with negative 2 charge, calcium, positive 2 charge, nitrate, negative 1 charge. Now, I just need to count how many of each one of these on this side and then try to match up the other side by putting out coefficients as you needed, okay? So let's look at ammonium. So since there's a 2 down here, okay, there's a 2 here, that means there are 2 ammonium. Over here, as the given formula of ammonium nitrate, there's only 1. So you need a factor of 2. Okay, now again, this 2 as a coefficient goes in front of the entire molecule. All right, but usually people don't really put the parentheses, okay? I'm just trying to highlight what the meaning of this 2. All right, the sulfate, SO4 as whole thing, as sulfate as one whole thing, there's only 1 of it. Over the other side, calcium sulfate, there's only 1, but that's okay. Calcium, 1 of it, calcium, 1 of it. Again, okay, you should remind yourself, is the nitrate balanced? Okay, so over here, NO3, there's a little number down here too, that means there are 2 of them. Over here as well, 2. Even though it was because you're trying to balance the ammonium, but you'll quite constantly balance the nitrate as well. So this whole thing is balanced by only putting the coefficient 2 in front of one compound. Everything else will be just 1, okay? You don't have the right one, but it wouldn't hurt to remind yourself there's 1 here, okay? Now, sometimes, okay, just sometimes, the questions on the test or on the homework will ask you to balance this equation by showing the sum of the coefficients. If you're ever asking for the sum of all coefficients, don't forget that these are 1s, okay? These are not zeros. In this case, it's actually 5 instead of 2, okay? Those are not zeros, okay? All right, so next thing is going to be, so this is checked. Next thing is going to be full ionic and non-ionic, okay? The full ionic is going to be, let's work it out together, okay? Again, feel free to pause here, see if you can work it out yourself. So the full ionic equation is going to be from left to right. Ammonium, NH4 plus 1 charge, aqueous, and don't forget, there's a little 2 down here. That means there are 2 ammonium. Plus, that goes in front as a coefficient, okay? Plus sulfate, SO4 as one thing, negative 2 charge, aqueous. There's only 1, okay? Now, plus next thing is going to be calcium nitrate, calcium plus 2, aqueous. Don't forget the charge, okay? And there's only 1 calcium. Plus nitrate, NO3 as one whole thing with negative 1 charge, aqueous. And there's again, there's a 2 down here. That means there are 2 nitrates. Anyway, you have to see these broken up compounds still remain as balanced charge, okay? This goes to first products, ammonia and nitrate. Now this coefficient, you have to be involved in the ionic equation as well. So 2NH4 plus 1 charge, AQ, plus 2NO3, negative 1 charge, AQ. And of course, plus calcium sulfate. This is calcium sulfate as a solid. It's unbreakable. So write it out, copy it down here just like that. Okay. So this is the full ionic equation. Okay, so that's down. The non-ionic equation will be simply identify the spectator ions. You can see ammonium, 2 ammonium. When I say identify the spectator ion, they have to be the exact same item in the same format, okay, same physical format, the same number. Everything has to be the same to be crossed out. and nitrate crossed out. So copy the rest of the equation out. That will be your net ion equation, which is going to be sulfate. Copy everything, okay, as it is aqueous, including all the numbers. So that would be another example of double replacement. This does take a little bit of practice, and usually if you feel struggling here, usually it's not because of the equation. If you feel necessary, go back to module 5. Module 5 is really really the foundation, okay? I can't overaddress this. Module 5, be really good at writing cation and anion from compound, or writing compound given cation and anion, recombine them. So that's really important, okay, to get through module 5 with solid groundwork.